Hello, everyone. Okay, hold on. That was about a solid 3 people. I need a little bit more than that. Let me try again. Hello, everyone. Oh, that's what I'm talking about. That's the energy that I needed. Okay, thank you. How are you guys doing? My name is Jovonne Cameron. I'm a software engineer and a technical writer. And I just want to give a shout out to Michelle, Gabe, and the whole React Miami team for having me talk to you all today. I'm so excited to be here. Oh my gosh. But I want to get to know you all a little bit better. Can we get to know each other a little bit better? Really quick, really quick. Let's play a quick game. And for my introverts, don't worry, you're safe with me. I'm not about to make you get up and walk around and speak to people. I just want to play put a finger down. So let's put a hand up. Put a finger down if you've been an engineer for more than 4 years. Okay, I see some seasoned people in the room. I love that. By the way, this is how you network without speaking to people. Keep an eye on who's putting what finger down, okay? So put a finger down if this is your first ever React Miami conference, excuse me, sorry. Okay, I see some first timers. Shout out to y'all. Y'all are in the right place. I love that for y'all. Put a finger down if you've ever copied and pasted code from Stack Overflow or ChatGPT. Oh, some of y'all cannot put your fingers down because you're next to your managers and your coworkers and you don't want to air yourselves out. And you know what? That's all right. That's very okay. Put a finger down if you've ever had to deliver a feature or meet a tight deadline with just coffee and vibes. Ooh, the procrastinators are showing themselves. Whoever put their finger down, therapy. We need therapy. Okay, last one. Put a finger down if you've ever pushed up code to production that cost your company $50,000. Ooh. It's just me? What? Quick, Simon says put a finger down. Okay, all right. I'll face the music. It's just me. That's okay. We're going to get into it today. We're going to be talking about avoiding expensive mishaps with effective state management. And so my goal here is to really just create a simple framework where we can avoid those costly mistakes and then make state management a little bit simpler, scalable, and stress-free. And we'll do this by having a brief overview of state management and going over a few techniques. And these techniques are not necessarily law, it's just something that I use as guidance, and you can take it and tailor it to your own unique situation. So I want us to be able to leave answering 3 questions. What causes these expensive mistakes? How can we prevent unnecessary API calls and performance issues? And then what's a simple rule we can use to kind of write better state logic today? Okay? Now, we're gonna address the elephant in the room. Can y'all read this with me really quick? 1, 2, 3. Girl, what happened? What happened? What do you mean 50K? What do you mean you lost $50,000? What happened? I'll say this, $50,000 is a bit of a subjective number. Some people, I tell them, and they don't even flinch. They're not batting an eyelash. Other people, they're gasping. They're clutching their pearls. Oh my gosh. It's me, I'm others. But as a junior engineer, I made this mistake. And that was a percentage of my salary at the time. So I couldn't fathom losing that kind of money in a matter of days. But on a really high level, it was due to really expensive API calls, excessive API calls. So I failed to cache the data properly, and it wasn't necessarily a problem until traffic spiked. So once the traffic on the site spiked, we had more calls on every page load, and before you knew it, our cloud costs skyrocketed. Okay, so picture this, we launched on a Wednesday, and by time we came back Monday, we were sliding down the wall. It was funny, but it wasn't funny at the same time. It was a time to be alive, actually. But let's take it a step further. Let's use an example. Let's break it down. So let's say Michelle calls us up and she's like, hey, we were wondering if you could make the e-commerce website for the official React merch for the conference this year. And we're on the other side like, yeah, you know what? Heck yeah, I got you, girl. So we do the site, and it comes out great. We're like, okay, cool. And just for example purposes, this is our very fake but fabulous React Miami store. And so people are able to browse the site, go through the products, checkout is great. And the problem is kind of invisible. That's the way it starts out, at least. And so imagine every time someone clicks a product, we fetch the details, we get the colors, we get the sizes, prices, inventory, etc. But we're not caching, we're not memoizing. This site is basically running on vibes and fairy dust at this point. So, but let's take a quick look under the hood. Let's look at it technically. Let's just say I could have pushed up something like this. This is just an example. I'm not saying this is what I pushed up. But here we have our product page and we're fetching products and we have a use effect with an empty dependency array. I should have known something was wrong right there. But that runs one time every time the component mounts. So if the component unmounts, then remounts, we have people just calling on this use effect every single page load, just by navigating the website or when the product ID changes. And so 50 site users a day is not really a big deal, but we're React Miami and we sell out. So of course, the site was going crazy when we launched it. And so until we get like 50, 60, 70,000 people, now we're in trouble because we never set our site up to scale. And now we have the expensive API calls, and the cloud company is sending us $50,000 love letters. But the love isn't mutual. We don't like this for us, right? So before we start walking into a couple of solutions, let's just do a brief overview of what state management is. I know we're at a React conference, bear with me, but I don't want to assume anything. So what is state management? And state management is basically how we manage our data across our apps, across our different components in our app. And so how we manage our data really determines how our apps perform, how they scale, and also how they're maintained. So there's a couple different types of state. We'll just go over 3 for today, but the first one is like local state, and that's just data that's stored in a single component. So that would be like a button toggle, for example. And then we have global state, which is shared data across multiple components. So that would be like a dark mode if we decided to implement it here. And then we have server state. Now, I could be very, very candid in saying that I didn't really take server state that seriously. When I was the junior, it was local state, global state, or bust. I wasn't really, everything outside of the app I didn't care about. So that has to do with the data that's fetched from an external server like an API. So what is the connection between poor state management and these expensive mistakes we were making? And it's important to know that React apps, that function off of poor state management, they struggle with things like overfetching, unnecessary re-renders, overfetching and unnecessary re-renders, lost data between the pages. And when the state is mismanaged or it's scattered, it leads to performance bottlenecks and rate overages and just real financial issues like a really heavy cloud bill, or even worse, degraded user experience. So that 50K figure I gave you was just the cloud bill. That didn't account for the sales that we could have lost due to poor app performance, poor checkout experience, etc. But we can definitely prevent these mistakes by trying to make sure that state lives in the right place and we don't overwhelm our system because we're reusing our data intentionally. And so that saves us time, money, and stress when we're scaling our apps. So what can we do about it? Like, what's a good way to solve or improve this issue? We already spoke that the problem really isn't in fetching the data. We just need to optimize all the calls that we're making, whether we decide to memoize, cache, whatever we decide to do. The point is to fetch smarter. And there's a couple of different ways we can do it, but for the example, we'll just use React Query. So just in case you didn't know, React Query is now 10-stack query, so if you're going to do a little bit more research, keep that in mind. But React Query really helps us out by managing how we simplify and fetching, caching, synchronizing, and updating in our app. And so why would we choose React Query? What's the point, right? So one of our solutions is that we want to cache. And so React Query does that automatically. It stores our API responses instead of reusing and reuses the data instead of fetching every single time. And then it also does background refetching, and it fetches new data only when it needs to. So now we're already saving on those calls that we were doing. And then lastly, one really cool thing that I like about it is that it has automatic error handling. So it handles errors outside of the box. There's no need for the extra try catches, and it retries on failure. So let's implement it. Let's go back to our product page. So we have our query key that's unique for caching, our unique key for caching, and then we have a function that's a fetch product that will fetch our data. And then if it fails, it'll retry 3 times based on our example here. So it'll retry 3 times and then delay after each time. That's what we call an exponential backoff. So it'll try, if it fails, it'll wait, try again. If it fails, it'll wait a little bit longer and then try again, as many times as we set it. So just how we have our product here, we will fetch the data once, save it for a little bit, and then refetch after our stale time. Our stale time here is set for 5 minutes. And so overall, React Query helps us cache on the server side. But what about the global side? What about global state? Can we cache in global state? Is it worth it? Should we try it? All the things, right? So this will help us with our app performance. Remember, our 2 problems was the excessive API calls and our degraded app experience. So this will help with the performance. And when you have those excessive calls with all that heavy site traffic, it can really be a user experience nightmare. And so we can cache that data many different ways, but we're going to use the example of Zustin today. So Zustin is a state management library in React, and it gives us a simpler way to kind of manage global state and helps us out with the unnecessary re-renders. And again, just like React Query, why would we choose Zustin? So it has a few similarities. It caches as well, but for global state. So we're storing that API response and we're using the data before fetching again. And then this is the key part of it right here. We're doing performance optimization. So it stores state outside of React's rendering cycle. So that means that the updates aren't forcing re-renders. And then lastly, one of my favorite things is that it's pretty choosy. So it has selective re-renders. So the components that use specific parts of the store only re-render when that part changes. Again, let's put it together. Here we have our product store, and we're still fetching the product, but we're going to check for the product ID in that product object first. And if it exists, we'll just return early. But in the second part, if it does not exist, we'll just fetch the details and then store it in our API there. And so now that we spoke about caching in global state and server state, what's something else we can do to kind of prevent these types of mistakes? We can put in some preventative measures. So one thing we can do is set alerts that will just catch the spikes before they get expensive. Now, back at that time, I would have really loved an alert to say, hey, girl, you're doing a little too much. XOXO, your API calls. We can also use rate limiting to prevent runaway API calls. And then on top of that, we can just monitor and track our API usage to detect anomalies in real time. So all of these three things combined can be done in-house. You can make your own functions and also test them as well. Or you can use a cloud platform or API that offers API management. So we have Sentry, LogRocket, Azure, Datadog, the list goes on, right? So what is that simple rule we were talking about earlier that will help us make that will help us make better state logic today? So I have a rule, I call it the 3-2-1 rule, and this is what helps me make my decisions whenever I'm dealing with state. So it consists of 3 questions, 2 strategies, and 1 golden rule. So my 3 questions are, I always ask myself, where should the state live? How often is it used? And what does it affect? That helps me to make that decision of, should this be global? Should this be local? How do I want to go about implementing it so that it doesn't run away from me? And then the 2 strategies, just as we spoke about, is caching intentionally and monitoring. So when we cache intentionally, we can make sure that our app performance is still doing pretty well. And then when we monitor, we can catch our mistakes before they get out of hand. And then we have our 1 golden rule. Simplify. What's that saying that they have? KISS, keep it simple, sexy, or keep it sexy and simple, something? Okay, I don't know. But the point is that state can get pretty complicated very quickly, and it's very easy to get tool fatigue. So my simplify rule is just to make sure that I'm only reaching for these tools when I absolutely need them. Because if you do it too ahead of time, you can overwhelm your teams and you can also make debugging an absolute nightmare. And I'm wrapping up here, but I wouldn't be me if I didn't talk about the mental side of making these kinds of mistakes. By a show of hands, how many of us like or love what we do, but we know it could be very stressful? The jobs be stressful? Managers, please look. Look who's raising their hand. So it does bring on a lot of different emotions, but I really came to this talk in hopes of sharing my transparency and submitting for the perspective that failing fast and pushing forward anyway brings about some of the best outcomes. So I'm speaking specifically to engineers who have made mistakes or are afraid to make mistakes. You don't know what good can come out of you and your company by giving yourself that grace to make $50,000 mistakes. It's some of the things that will unlock a whole new character, and it'll create opportunities like this one. That's part of what got me on this stage today. And so for the managers and the team leads, this is a great time to practice empathy and encourage your team. So when I made that mistake, of course my manager was concerned and sliding down the wall with me. But he came from an angle of, how did it happen and how can we prevent it? He never blamed me. And it brought our team so close and it really boosted the morale. And then when I spoke to my mentor about it, she said, failure is really frustrating. But failure isn't fatal, it's not final, and it's not fruitless. Something will always come out of that. It's all about your perspective about what will come out of that. And so if you want to know how the story ended, it ended pretty well. I was able to get that $50,000 bill waived. And if you want to know how, you can just pull me to the side outside, but keep it on the low. But for now, let's connect, let's collaborate. I've also made a 1-pager on state management for you, completely free, talking about the things we spoke about today and going into even more detail. I just want to take a quick moment again to thank you all for your ears and your eyes. I am having so much fun. Let's keep building.